We've already mentioned that an adequate design providing a good user experience must make the best use of the space available in the user interface. This implies that the amount of information and how it's displayed must be different on a small screen mobile device, such as a phone, compared to a desktop computer or a big screen monitor. Let's learn more about these concepts. To design web applications that are optimally designed for different screen sizes, there are two possible approaches. One is responsive web design, which uses a single design and adjusts the content, navigation, and page elements to fit the user's screen. Responsive design will rearrange all design elements, which can be viewed on a big screen, desktop, laptop, tablet, or cell phone. Another approach is adaptive design, in which different fixed designs are created for each screen size of the users. Unlike the automatic adaptation approach, adaptive design uses several layouts with an optimal design for each screen, which are automatically run according to the platform detected. When designing a responsive design, all screens and devices on which a user can view the application must be taken into account. Certain elements may work and align very well in a large desktop view, but if smaller screen sizes are not taken into account, the design may not scale properly to their size. With adaptive design, the website will detect the user's device type and will use the layout designed to fit that screen. While designing for each type of device requires more effort, the benefit is that the designer can have more control over the design elements and achieve a better user experience. For this reason, most new websites now use adaptive design. Genexus allows us to implement applications with both design approaches, using web panels when we want to make a responsive web design, and using panels for an adaptive design. Now we'll focus on adaptive design, creating multiple layouts for the same panel object. When we create a panel, a default layout is already created, which is the one we've used so far. To create more than one layout for the same panel object, there's a toolbar at the bottom of the layout, consisting of a combo box and two buttons, one to add a layout and one to delete it. The combo box, by default, gives the option for the layout to be created to fit any platform and for the default orientation. However, pressing the Add Layout button opens a dialog box that allows selecting the following: platform, device kind, size, any size, and only when we select in device kind a phone or tablet, the values phone, tablet 7 inches, and tablet 10 inches. Version, with the value any version, and which, depending on the case, allows us to select the platform version. Orientation, default orientation, landscape, and portrait. And mode. When we're in a Work With Pattern Detail screen, we can choose the mode, any mode, view, or edit. After choosing the values for each option, we click on Click Here, and the selected layout will be created. Note that if we don't choose any option from the combos, any platform and default orientation will be used for the layout to be created. Here's an example of multiple layouts created in a panel object. The corresponding one will be automatically executed according to the screen size and device type. When running the View Attractions More Info panel, we have a horizontal grid that shows 5 attractions at a time, and if we move to the right, we see the rest. This is because we defined the panel grid as a horizontal grid with the property column per page portrait set to 5. This view is fine, but let's look at a case where a different design is needed. Suppose the travel agency wants a 65-inch TV in its office to display the attractions in a horizontal grid so that more attractions can be seen at the same time. When we implemented the panel, we saw that any platform is used by default and it works. However, if we want to create a specific layout for web and optimize for a browser that runs on a certain screen size, such as a large screen with landscape orientation, we could do that too. Let's create a layout with these characteristics for our View Attractions More Info panel. We click on the Add Layout button and choose Web Platform. Then, in the device type, we leave the default option Any Device Kind, since it will not be a tablet or a phone. In size, we choose Big Screen. In version, we leave any version, and in orientation, we choose Landscape. Finally, we click on Click Here. The layout we defined is created, and here we can make the design changes we want to optimize the way the panel information is displayed, which will not affect the other layout we had before. If we press the combo arrow, we see that now there are two layouts defined: Any Platform, default orientation that was the default value, and the Web Big Screen Landscape that we're creating now, which appears below and to the right of the first layout. We can see that a hierarchy is going to be established, since the layouts are shown as a tree. This means that if we're running on a big screen, it'll choose that layout, and if we're running on another device, it'll choose the first one, Any Platform. This is to say, there's a level of precedence. The closest to the platform we're executing will be the one applied. Otherwise, the layout that's highest in the hierarchy will be applied. In this design, we eliminate the filters and the total number of trips. In the grid properties, we leave the horizontal grid, but change the columns per page to 10. We run it to see what we did. Note that we no longer get 5 attractions, but 10, and that we no longer get the filters or the total number of trips. This means that the big screen layout design we created is being used. Why is that, if we don't have a 65-inch screen? To find out the answer, let's go to the defined platforms and see how the big screen platform is set. We go to Customization, Platforms, and to the Web Big Screen properties. We can see that the minimum longest bound property is set to 1200 dips, which in Angular is the equivalent to 1200 pixels. If specified, this property determines the minimum width or height in dips applied to the platform. Since my notebook is full HD, meaning it has 1920 by 1080 pixels, the value of 1200 is exceeded. So Genexus assumed that my notebook is a big screen and used the specific design we created for that type of screen. To check what would happen if we had a smaller screen, let's press F12 and select the size of an iPad with 1024 by 768 screen. Note that the previous design appears, which includes the filters and the total number of trips. Remember that this design was set to any platform default orientations, which means it's valid for any screen size less than 1200 pixels in height or width. We've seen how we can have multiple layouts for the same object and customize the way each layout is displayed. Genexus will use the design best suited to the platform where the application is being deployed. To end this topic, we'll see some situations where we should use different layouts. For the same information in a desktop application, I want to use one design, and in a mobile application, I want to use a different one. In the same application, I may want to use one design for the web front end and a different one for the native mobile front end, even if they have the same screen size. On the same platform, I want to use one design in portrait mode and another in landscape mode. On the same device, I want to use one layout if I'm editing an entity and another if I'm viewing it. In this video, we saw how GeneXus allows us to use an adaptive design approach and have different screen designs as needed. In future videos, we'll discuss more design concepts for our application.